In this video, we'll be graphing the following quadratic function, f of x equals 2 times 2x minus 5 times x plus 1. So currently it's in the factorized form, so the easiest thing we can find is the x-intercepts, which occur when y equals 0 or f of x equals 0. So to do that, we have 0 is equal to 2 times 2x minus 5 times x plus 1. And now we use the null factor law, which states that if a times b equals 0, then a could equal 0 or b could equal 0. So in this case, we can have 2x minus 5 equal to 0, or we could have x plus 1 is equal to 0. So solving for x, we add 5 to both sides. So add 5, and we get 2x equals 5. Therefore, dividing by 2, we get x is equal to 5 on 2. Similarly to this, we subtract 1 from both sides of the equation, and we get x is equal to negative 1. So the next thing we can do is we can find the y-intercept by letting x equal 0. So in this case, we're going to have f of 0 is equal to 2 times 0 minus 5 times 0 plus 1. So we get 2 times negative 5 times 1, which is equal to negative 10. Therefore, y equals negative 10 is the y-intercept. Finally, we need to find the turning point. And we can do this several ways. So we could complete the square, which is what we're going to demonstrate in this video. So we can also write f of x once it is expanded. So if we expand this, we get f of x is 2 times 2x squared minus 5x plus 2x, so minus 3x, and then we get minus 5 as the final expansion of those two brackets. So remembering that for completing the square, we need to make sure the coefficient of x squared is 1. So we can take the 2 out. So we get 4 out the front of x squared minus 3 on 2x minus 5 on 2. And now we can go about completing the square. So the first thing we do when we're completing the square is we look at the value at the front of x, or the b term, and we halve it. So we have 1/2 times the b term, which is negative 3 on 2. Which gives negative 3 on 4. And then we square that term, which in this case will give us positive 9 on 16. So when we complete the square, we're going to take the first couple of terms, so we still have the 4 all the way outside the front of our equation, so 4 out the front of the equation. We have x squared minus 3 on 2 times x. Then we're going to add on 9 on 16. Subtract off 9 on 16, and then of course we've still got minus 5 on 2. So continuing on, the 4 stays out the front, and the first 3 terms, the reason why we completed the square is that these are a perfect square. So we can factorize these as x, and it's going to be minus 3 on 4 all squared, where the negative 3 on 4 comes from the half b term over here. And then minus 9 on 16 minus 5 on 2 is still remaining. So if we do a quick calculation, minus 9 on 16 and then minus 5 on 2, which is the same as minus 40 on 16, gives minus 49 on 16. So that's what we're going to put in here, minus 49 on 16. Then the last thing to do is just to distribute the 4 through. So we get 4 times x minus 3 on 4 all squared minus 49 on 4. So this tells us that the turning point is at positive 3 on 4, comma negative 49 on 4. So now that we've got all this, the final thing we have to do in graphing is to plot all the key features, which are the x-intercepts, the y-intercept, and the turning point, and then just put a parabolic shape through those points. So the first point we're going to put on is the x-intercept. So we had x equals 5 on 2, which is here, so 5 divided by 2, comma 0. And then we also had negative 1, comma 0. And then the y-intercept occurred at negative 10. So negative 10 is somewhere around here. So this is going to be the point 0, comma negative 10. And then the turning point is at 3 on 4, and then negative 49 on 4, which is about negative 12.25. So it's going to be somewhere around here. So we're going to have 3 on 4, comma negative 49 on 4. So joining these up with the parabola, we're going to have it going through the x-intercept, through the y-intercept, and back up through the second intercept. So here it is graphed by a computer. So we can still see that we've got our x-intercepts here and here, our y-intercept, and our turning point. And they are the key features for graphing any parabola.